So now that we've talked about the implementation of the TaskGang class and walked through that, that's the superclass, the abstract superclass. Now let's take a look at the ImageTaskGang class. And as you may imagine, that's going to extend TaskGang, and it's going to fill in a whole bunch of the abstract methods in TaskGang in order to actually do this image processing concurrently using the executor completion service. So as you can see, it uses the executor completion service to concurrently download images from these web servers or the local file system if we're running in local mode only. It'll apply a bunch of image processing filters, which will also run concurrently, and then it'll store the results in the local file system of whatever device we've used to download the images and process everything and filter everything. And as I mentioned before, this implementation uses the template method pattern where, for example, the run hook method that's defined in TaskGang is going to call back to a bunch of hook methods that are defined in ImageTaskGang in order to do the actual image processing that we're going to need for this particular application. There's also the proactor pattern used here, and you can see also the future pattern. So we're using proactor in order to be able to get the processing between the ImageTaskGang and the executor completion service to run asynchronously. And this allows us to do the processing in a scalable way using this pool of threads. The future, as you can see here, is used to provide a proxy for a result that may not be available yet. So the program can continue execution without blocking until it really needs the result. We'll see how that works in just a little bit. And of course, it also uses the pooling pattern from the POSA 3 and POSA 4 books. So let's go ahead and take a look now at the source code for ImageTaskGang, which you can get in this file in the ImageTaskGang folder in my Live Lessons GitHub repository. So here we are back in the ImageTaskGang project. Let's look in tasks again, the task package again, except this time we're not going to look at TaskGang, we're going to look at ImageTaskGang. And ImageTaskGang customizes or extends TaskGang, filling in URL as the element we're working with here. And it's also going to use the Java executor completion service to download this list of images from web servers or local file system, apply a bunch of image processing filters to each image, and then store the results in local files that can be displayed to the user or the users by various means. And that's something that I don't really show in this command line version, but if you look at the Android version, you can see we could display it in different ways than we would display it here. This class, the ImageTaskGang class, implements the roles of the proactive initiator and the completion handler in the proactor pattern, and also plays the role of the concrete class in the template method pattern. And I'm actually a pretty big fan of using patterns as part of the documentation, because once you know the patterns, you have a better sense of what you're seeing. Now, we visualized this earlier, and that might be overkill for some use cases, but having the comments in the code really helps to see what we're doing. So here we use an iterator. And of course, an iterator is yet another pattern. I probably should have mentioned that earlier. An iterator is a pattern that appears in the Gang of 4 book. And it's used to get access to lists of URLs. So we have an iterator to a list of URLs, and we'll see how that's used in a minute. Then we've also got another field called mFilters, which is a list of filter objects that are going to be applied to the downloaded images. And we've got a bunch of those as well. So the next thing we have is the executor completion service field, which is parameterized by image. So that's what we're going to be working on. And this particular field plays the role of the asynchronous operation processor in the proactor pattern. And that's what we're going to use to do the concurrent processing. And then we also have the name of the test, which we use for diagnostic purposes. So here's the constructor. You can see the constructor basically takes the array of filters. It takes a list of lists of URLs. It takes the name of the test, and it takes the executor service it wants to use to actually do the concurrent processing. And it converts that array of filters into a list and stashes that into the mFilters field. It takes the URL lists method and calls .iterator on it to get an iterator, which we stash in the mURL list iterator field. We stash the test name in the field. We set the executor, and then we go ahead and we create a new executor completion service, which is connected or bound to the executor. That's the way executor completion service works. It's basically a kind of a wrapper around an executor. which we'll be able to parameterize here. Now let's take a look at some of the methods that we overrode from the TaskGang superclass. One is the getNextInput method. And what we do is we say, while there's anything left in our iterator, let's note that we are starting a new cycle. Let's increment that by 1. And then let's get the next element from the iterator. Let's get the next list of URLs to download concurrently. So that's what's going to come back in the call that's done in the template method back in TaskGang. There's also a method we're going to see here called get or download image, which is just going to go ahead and download the image. It takes a URL, and it just goes ahead and creates an input stream that connects to that URL. And then it reads each buffer size chunk, which is basically 4K, into an array of bytes, and then it writes it to the appropriate output. So that's what download content does. It basically downloads it, and it's going to store it into an image. And then here's the process input method. This is also overridden. You can see the first thing it does is it takes the URL to download, and it calls get or download image, which we just looked at up there. So that goes ahead and starts the downloading process. Keep in mind, this method is running in a background task. It's running in a thread in the appropriate thread pool that we've created, either a fixed size pool or a cache pool. Then once we've downloaded the image successfully, for each filter that we've been configured with, we're going to take that filter and we're going to submit it to the executor completion service using the submit method, using a Lambda callable. That's what this thing here is. And the call method on the Lambda callable, when called, will run, of course, in a thread, in a worker thread, in the pool of threads that we've designated for this particular ImageTaskGang instance. And we're going to go ahead and create an output file decorator. And then we're going to say, hey, output file decorator, please go ahead and filter the download image, which will have the results of storing it. It'll process the image based on the filter it, and then it'll store it into a file and return the resulting image. So that's what's going to come back from this, is this image. Here's the InitiateTaskGang hook method. This is going to be called when everything starts up. And you can see what it does. It iterates through the number of URLs that we've got in our list of URLs to process. And for each one, it's going to call that makeTaskFactory method, which is also a template method, which is going to go ahead and make us a runnable that's going to take that item at that index location in the list, call process input on it with that element, and then when it's finished, it'll call task done. So notice that by executing this, this means that this will run, each of these calls, each of these runnables will run in a thread from the appropriate thread pool that's running in the background. And we're going to do that with whatever executor we've been provisioned with. Here's the await task done method. This, remember, is called back from the calling thread, the one that called run on ImageTaskGang, or really TaskGang in the first place. And what it does, it's pretty cool. This is going to run, and it's going to figure out how many futures do we have to process. There's going to be one future for every image that we're processing, every filter that we're applying. So we take the number of filters times the number of images, and then we're going to call this helper method called concurrently process filtered results. And we're going to pass in the results count. And I'm going to go look at that method right now, and then we'll see what happens when this thing returns. So concurrently process filtered results is going to iterate in a loop from I equals 0 to I less than the results count. That's the number of total images we've started off asynchronously running in the executor completion service. And for each of these things, we're going to call the take method on the completion service. And take, as you may remember from watching the videos that describe the asynchronous completion service, is going to take the next available future off the executor completion service's completion queue. This call may block if there are no items on the queue yet. If there are items on the queue, it'll just take the next one off in a nice, thread-safe, properly synchronized way. Once we've got the future, then we can turn around and say, get the result. And notice when we call get, that will not block. So the call to take may block if there's nothing there, but this call to get will not block. And the reason for that, of course, is that these futures don't end up on the completion queue unless they have in fact completed. So we know that this will never block. And then we just go ahead and kind of print some diagnostic output if we're in that mode. We check to see if we succeeded or failed. We increment the count appropriately. We also check for some exceptions that could have occurred. And then depending on various factors like, is this a test run that's a warm-up test, or is it a real test? we then print how many operations succeeded and how many operations failed. So that's the walkthrough of ImageTaskGang's implementation. With one little exception, I didn't tell you what happens after we're done with this processing. So what happens here back in await task done, we then check to see, is there any more input or are we finished? If we're finished, we break out of the loop, we're done. Otherwise, we initiate the task gang again for the new set of input to work on. And you can see we do that by calling get next input. So as long as there's work to be done, the await task done will kick everything off again, initiate task gang, as we just saw, will start all the tasks running in the background, and then this will loop back around again and then call concurrently process filtered results, which will block until that round or that increment is finished, that phase is finished. The very last thing we do in await task done is we actually await some other things. And if it turns out the executor is an instance of executor service, which it should be, but we don't, well, it should be. There's should not be the case. It's not an instance of executor service. We shut down the executor service and then we wait for this amount of time. We basically wait for an indefinite amount of time for all the tasks to complete gracefully. Now, if something really horrible has happened, we might want to bound that wait to not wait indefinitely, but there shouldn't be anything horrible that's happened here. So this will just basically return very quickly after that. So that's kind of showing how things work. Notice this is showing how things work. Notice, by the way, that this is a newer Java feature. This is why I'm doing this in the command line version, because I can use newer Java features where you can make yourself an object if instance of succeeds. So you can basically do this. It's kind of like you're defining a variable in the context of the condition of an if statement. And that's a fairly recent Java feature. So we couldn't have used that in the version of Android that we're working on right now.